Welcome everyone to this SORMAS Foundation webinar presentation. My name is Obinna Henry. I am a software developer with the foundation for over 2 years now. So this presentation basically will provide practical troubleshooting steps. And this is to help to minimize issues during installation, development, upgrades, and routine operations. And the target audience are SORMAS developers who customize SORMAS for their implementing countries or who want to contribute to SORMAS, and also for system administrators who manage the servers where SORMAS is deployed. So this presentation is not for beginners. We expect that you are comfortable with the Linux shell, and you also understand SORMAS development stack and architecture. And during this presentation, we'll cover server installation and setup. So those will be covering issues that are common from experience and may usually come up during server installation and setup. Also, we'll cover issues that happen during when a system administrator is upgrading SORMAS. So maybe there's a new version and you need to update SORMAS. So there are common things that could happen. We also cover how to troubleshoot such issues. And then for the software developers who actually work with SORMAS code, we'll also discuss some issues that come up often and how to also resolve them. Okay, so this presentation will focus on the standard SORMAS technical stack documented in the SORMAS wiki. So the operating system will be Unix. The version of Java will be JDK 11. The application server is Payara server. The database with PostgreSQL 14 and 15, which are the versions that SORMAS supports. And Apache Web Server as a reverse proxy to Payara. So I will want to cover how the different components of the SORMAS technical stack interact with each other. So typically, you have your deployment on a Unix server, preferably Ubuntu, which is what the guide assumes. So within Ubuntu, you have the Apache Web Server, which serves as a reverse proxy to the Payara server. So the idea is that the Payara server cannot be publicly accessible. So all the ports, the standard ports for SORMAS 6080, 6048 for Payara server are bound to localhost IP on the server. So this is for security reasons, because this is where actual SORMAS is actually deployed. Then we have the PostgreSQL database also within the same Ubuntu server. Of course, like I mentioned, this is a standard installation. It is possible you have your database on a different server, your Payara on a different server, but the whole idea remains the same. So SORMAS has many modules, but there are 3 core modules. The SORMAS UI, which is where people access the SORMAS application from a web interface. This is a Vaadin-based user interface module. Then we have the SORMAS REST API, which is used for integrating external systems to SORMAS. This also serves as the communication layer between the Android mobile application and the SORMAS backend. Then you have the SORMAS backend. So each of these modules of SORMAS are independent modules. They are not packaged as one archive, a WAR file or an EAR archive. So the SORMAS UI is a web archive, that's .war. SORMAS REST is a web archive, .war, and then the backend is an enterprise archive, that's .ear. So the idea is when a user is accessing SORMAS from a web browser and they enter the URL for their SORMAS deployment, that request goes to the Apache web server, which is publicly available. And then the web server now proxies that request internally to the Payara server. Because this is a browser request, the proxy configuration directs this request to the SORMAS UI module. Okay, then the SORMAS UI module can then interact with the SORMAS backend module to fetch data or to insert data or to run reports and then return the response to the client. The same thing happens if you're accessing SORMAS from the Android mobile application. Any request entered also goes to the Apache web server as a reverse proxy, but this time around, the request is proxied to the SORMAS REST API module, which then communicates with the backend module and then returns a response to the Android user interface as well. So access to the database is only through the business logic components of the SORMAS backend module. So the SORMAS REST module, the SORMAS UI module never accessed the PostgreSQL database directly. So we'll begin with the first scope that we're going to cover, SORMAS installation. And we assume that the installation is following the official SORMAS guide at this URL in the SORMAS wiki. The first thing to do is to install certain packages on Ubuntu. So these are pre-set up checklists. Okay, so the possible issue here is that you could run the server setup following the guide, and then it just exits abruptly, and you don't know why. Or the whole setup completes, but you cannot start the Postgres database. The Payara refuses to start, and other related services also refuse to start or communicate with each other. The reason for this is that the server setup script is a Unix shell script. So it uses certain Unix commands to execute the installation. So if some of these packages are already missing, you will have this kind of issues. So one typical example is permissions. The script uses ACL package of Ubuntu to set permissions on the directories for Payara, Postgres, and other components of SORMAS. So if this package is missing, the script could continue and complete successfully, but then you have issues interacting between Payara and Postgres, or starting Payara or Postgres or other components as well. So the best thing to do in this situation is to first update the server's system package list using apt-get updates. And remember, you have to run these commands as a root user or a user with sudo privileges. Then the next set of packages to install is ACL. So you have the command there, apt install ACL. Then the script also downloads Payara zip file from the internet, extracts it, and does some configurations. So it calls the command wget. It uses call. It unzips it using the unzip command. So if some of these packages don't already exist in the operating system, then you have this kind of issues. So this slide gives you the commands to restore ACL, wget, call, unzip, and zip. And after installing them, it will be good to confirm that before you run the server setup script, it will be good to confirm that they installed successfully. So you can use the last command, which wget, call, unzip, zip, set facl. The idea is that the output for that command should give you a list of the paths to these commands on the system. If anyone is missing, then please reinstall that specific package. Then the next package that the setup script uses is to compile PostgreSQL extensions. And that package is called GCC. So you also do an apt install GCC and have it readily installed. I will just try to show us what the setup script looks like so that we can understand why these are important. Okay, so here is a version of the server setup script in our repository. So following the guide, when you download a SORMAS release, this file is there and the guide tells you to run this file. So if we scroll down to where certain users are set up, for example, this command is trying to add the Pyara user. So you can see add user. Then it's using the set facl. So this is used to set permissions for this user on these directories. And you can find these directories and where they point to here. So you can see Pyara home is in OPT Pyara 5, domains home, OPT domains. So if you do not have ACL installed, this whole block could complete successfully, but Pyara will not be able to start because the Pyara user does not have read, write, and execute privileges on the domains home and other directories. Same thing for the PostgreSQL user that is used to manage starting and stopping the PostgreSQL server. It also requires permissions on these directories as well. So this may fail silently, but you cannot run SORMAS afterwards. Then you can see downloading Pyara, it uses wget to download the zip file in this URL. After downloading it, it has to unzip it to the Pyara home variable, that's OPT Pyara 5. So you can see that the server setup script assumes that these packages are already installed. So if you don't have them already installed, you will run into some issues. During SORMAS setup as well, some issues could come up, especially regarding the PostgreSQL version. So the idea is that the server setup script could complete successfully, but when you're now deploying the SORMAS application, which usually starts with the SORMAS backend module, the deployment may fail because of version incompatibility. Because the guide points to PostgreSQL's installation guide. And if you're not careful following that guide, you may install the very latest version of Postgres. And SORMAS at the moment only supports version 14 and 15 only. So this is caused by, it's mistakenly or accidentally installing Postgres using the command as specified in the Postgres documentation, which the SORMAS guide points to, without specifying the specific version you want to install. So if you run that default command, it only installs the default current latest distribution of PostgreSQL. So the setup script may properly set up the SORMAS schema and all that, but when you're now deploying, which is where the tables and every necessary migration is done, then you have this issue. The deployment fails or the upgrade fails. So the solution to this is to run that command with a specific version. So for example, you do apt-get -y install Postgres -15. So this would install PostgreSQL version 15 only and not the latest version of PostgreSQL. For Windows, this is for development purposes only. When you're setting up SORMAS for development on your Windows server, if you do not have the version of PostgreSQL assumed by the server setup script, you may run into some issues. So during your local development setup, the server setup would fail because it cannot locate where the PostgreSQL binary on Windows is installed. Now, the cause of this is that the script defaults the PostgreSQL directory to version 14, okay? C program files, PostgreSQL /14. Even though at that point, if it does not find PostgreSQL, the script will point you or require you to type the install path for the Postgres version you have, which is fine. But usually there are these issues of, Windows with / or / or /. This is a problem with directory paths in Windows. So the solution to this is, before executing the script, you edit this path in Windows. Now, if you scroll down the setup script, you'll find a line where you have PSQL_default equals to, you can see it's going to program files, PostgreSQL 14. Then it's, like I said earlier, it will ask you, if it doesn't find it, which is okay, so maybe you have 15 installed on Windows, it will ask you to enter the install path. But this is usually problematic because if you put /, sometimes Windows takes it. If you put \, it doesn't accept. So to avoid this issue, open the server setup script with a text editor and edit this line, change 14 to 15 as you have it on your system. Save it, close the text editor, and re-execute your server setup script. And then this will resolve the problem. Now we go to the second scope we'll cover, which is SORMAS update. And the guide to updating SORMAS is at this URL. Now, just to make a distinction, what the server setup script does is to prepare the environment. It does not deploy the SORMAS modules or the application. So the server setup script checks that you have Java, the right versions, it downloads the right version of Pyara, extracts it, configures it. It also sets up the SORMAS schema in the database. but the schema is empty. It just creates the database called SORMAS_DB. No tables, but it creates the user, the database, and grants the right permissions. So this is mostly what the server setup script does. It just sets up the necessary infrastructure on the server, connects everything together for you automatically. Now, to have SORMAS, to be able to use SORMAS, you must update SORMAS. So that's what we refer to SORMAS server update. So there is a script for that called server-update.sh. And the guide to do a SORMAS update is at this URL. So the typical workflow is server setup is done once. After you do it, you also do SORMAS updates to have SORMAS running. Now, anytime there is a new version of SORMAS, you do not need to run server setup again. You only download the new version of SORMAS, cd into the directory where this script is, give it the necessary permissions, and execute it, and it will automatically deploy the new update of SORMAS for you. Okay, so this slide explains what the server update script does in summary. It deploys and updates the SORMAS application. So it deploys it removes, if there's any existing deployment, it removes the existing deployed archives and redeploys the new modules, SORMAS backend, UI, and REST, and the Android application as well. Then it checks whether all the directories are there. It stops the Payara domain, removes the old domain libraries, creates a new backup of the database so that in case the update fails, you can restore your database. Then it restarts Payara and then removes old artifacts and deploys the new files, and then shows you the status of things through the server log on the screen on the terminal, so you can monitor the status of the update. Now, one common issue that happens during server updates is that at the stage where the update script needs to stop Payara server doesn't actually stop, and the script tries to continue. So you get this error message, Payara SORMAS was not found, or that trying to manually stop it failed. So this is it's not an issue of SORMAS or the script itself. It's a Unix time. I think it's a Unix timing issue. So if the Payara server is taking time to actually shut down, maybe it's trying to stop, some cron jobs and things like that, the script may not wait. It may just, after a few seconds, attempt to continue executing itself. So you run into this problem. So when it happens like this, doesn't happen all the time, but it does happen. What you do is that you find the running Payara server and kill the process, and then rerun the server update script, and then everything will be fine. So the first thing is to find the running Payara process with the first command. It is important to specify opt domain SORMAS to the grep command in the first command on this slide. The reason for that is it is possible that you have other Payara domains for other applications to use on your server so that you don't stop the whole Payara server. So we're only saying the process of Payara that is tied to the domain in opt domain SORMAS, which is the standard SORMAS domain directory. So when this command returns, then you are able to see the process ID. Then you can use kill and the process ID to kill it. You wait a few seconds, run the first command again just to check if it is still running. If it is still running, then you can forcefully kill it with -9. So kill -9, then the process ID. then the process actually dies, and then you can run the server update script again. So what happens is that when it gets to the point of stopping per error, it's already now stopped. So it will now go ahead to start it. And because it's a clean start, everything now works correctly going forward. The second issue that could come up during updating a SORMAS server is that the backup step is kind of stuck. So the idea is that you get stuck at this message where the script says creating database backups, and it just stays there for a long time. And somehow, this should have completed after a couple of seconds or minutes. One possible cause of this is that if it's an if it's an implementation that has a lot of data in it, and the database has grown to gigabyte range, maybe 1, 2, 3 gig and stuff like that, the update script actually performs a full backup, and it does not do this in a compressed format. So it could take a long time to actually complete that step before it continues forward. It is an important step because it does not want you to lose your data. So we do not advise keeping this step. So what we advise is interrupt the script, Control C, we usually do that. Then do a manual backup of your database using a compressed format. When that is done, now you know your data is safe. You go back to the script, open server update.sh in a text editor, Nano or whatever editor you prefer. Locate the line where it's displaying creating database backups. Just below that line, you will see the pgdump command. So what you do is to just comment it. And to comment in bash scripts, you use a hash sign. So you just put a hash sign before the sudo in that second line. You save it, and then you rerun the script. So what will happen this time is that you will see the statement creating database backups, but it will just jump to the next step. It will skip doing the backup, because now you have a safe backup of a database. You have achieved the same thing the script was trying to do. And the third scope we'll cover concerning troubleshooting is SORMAS development. And we assume that you are working from the official repository of SORMAS at this URL on GitHub. Now, we'll walk through an overview of the SORMAS code base. SORMAS is a multi-module application, each module serving a specific purpose. Now, while there are several modules in SORMAS, some are supporting modules, as a developer, you mostly work across 4 or 5 modules in your day-to-day activities. Now, these 4 or 5 modules include SORMAS minus API module. Don't confuse the word API to mean RESTful API. No. This module, SORMAS API, is the shared module of SORMAS. All other modules utilize this SORMAS API module. So it contains shared classes, shared enums, domain models, interfaces to connect the UI module to the backend module, internationalization, property files, and commonly used artifacts across other modules. So it's very, very important. The SORMAS backend module has the core backend business logic, which are mostly enterprise Java beans and core server-side functions. The SORMAS REST module, this is the actual RESTful APIs used for integrating external systems to SORMAS. It is also used by the SORMAS UI module, and then it serves as the layer of communication between the SORMAS application and the SORMAS backend module. And the SORMAS UI module is the Vaadin-based web interface. So this is how you access SORMAS from the browser. So it contains front-end logic, user interface components, layout and styles, and buttons for user interaction. Then we have the SORMAS app, which is the Android mobile application itself, the native Android mobile application. Now there are other modules for testing, performance benchmarking, authentication, packaging, server libraries, and other types of tools. These are not usually touched. Their contents are mostly automated, so you hardly do anything in them. Now, the SORMAS API module. This module is very, very, very important. It is the core shared module of the entire code base. So it defines enums, models, interfaces, and shared contracts. So it's the single source of truth for business concepts across the entire SORMAS code base. Now, why is this very important or critical? It is used by all major SORMAS modules. Understanding this structure saves you a lot of headache or issues while developing, because 80% of these issues during development come from issues with the interaction between this module and other modules. So it's used by all major modules in SORMAS. It ensures consistent data structures and business rules across the platform and reduces duplication of domain logic across modules. So now every module of SORMAS is self-contained. So for example, the SORMAS backend module, when it is built, it goes into SORMAS -ear.ear. If you build the SORMAS REST module, it goes into SORMAS -rest.war web archive. If you build the SORMAS UI, you get SORMAS -ui.war. So anytime you build SORMAS, these different modules are compiled or built into their different archives. Now, each of these archives have their own copy of the SORMAS API jar file, each of them. So this is very important because understanding this can save you a lot of issues. So the impact of the SORMAS API model is that whenever you make a change in the SORMAS API module, this change propagates system-wide or module-wide across the other modules. So if you have breaking changes in this module, it will affect the backend services, REST APIs, web UIs, and the mobile application. So it has to be carefully versioned properly. And the benefit of this is that you have strong modular boundaries, cross-module communication, and improves maintainability across the platform. So the key thing here is that it's the foundation of the SORMAS ecosystem. Every major module depends on it for shared domain definitions and contracts. So this is the language that the different modules use to communicate with each other. So it is important that we understand this structure. So one of the issues that can come up during development is usually because the SORMAS API jar file in the other modules are inconsistent. I will explain why this can come up during development, because sometimes if you make a little change in the SORMAS UI module, for example, and doing that, you also touched SORMAS API module. It is easy to forget to rebuild the entire SORMAS because you've touched the API module. But we just go and rebuild only the UI module, which gets its own latest copy of the SORMAS API, and you test it and everything is okay. Let me give an instance. Let's say a drop-down in the UI module is backed by an enum that is in the SORMAS API module. And there's a requirement to add a new value in that enum. So you go to the SORMAS API module, you add a new value to the enum. You go to, in the same SORMAS API module, you update the enum properties file, and you package API module. Then that's all basically you need to do, right? And you go to the SORMAS UI module and you make the necessary adjustments to accommodate this new value. Maybe another field is to be hidden based on this new value or something like that. And then, because you don't want to wait for the entire code base to be rebuilt, which takes some time because it has to rebuild all the modules, you quickly run maven install on just the SORMAS UI module, and you deploy just the UI module and you test it. So you're just focusing on the UI module and everything is fine. And then you only push the UI module to your server and deploy it, or even on your local host. You now want to submit that data. So maybe that dropdown is part of a form. You select the new value and you say save. Now you have an error message because the version of the SORMAS API module that is in the EA module or the backend module does not know about this new enum you've added and only compiled for the UI module. So you have this kind of problems. Okay, it's possible. So these are the different scenarios that can come up. So you, as a developer, you update one module, but you do not rebuild the entire project, which is controlled by SORMAS minus base. So the idea is whenever you do anything like that, you run install from SORMAS base. So possible issues is that the different modules and their corresponding EA and WAR files fail to deploy due to dependency version conflicts with SORMAS API module. Then you have class loading errors during startup. It's possible you renamed an enum, meanwhile what is coming in from the database has the old name, so you have to take care of this, think around it this way. Then other issues can also be runtime exceptions. You get errors like no such field error in the log file. You get errors like no such method error. You have illegal argument exception. This is a popular one where it tells you no enum constant found for this. So it means there's a mismatch between SORMAS API across the other modules. Or the mobile application trying to communicate with the REST module or through integrations, passing the request's input payload fails when values don't exist on the receiving side. Other issues that also come up with inconsistent SORMAS API versions in different modules is that you have UI anomalies, okay? So you could have added a new enum and worked on the backend and rebuilt the EA module and redeployed. But now you go to the UI, you can't find the new enum in the dropdown. So also if you have inconsistent versions, we're just using enum as an example so that it's clear to understand. You added a new enum that shows in a dropdown, but the SORMAS backend does not have the version of this SORMAS API. So when you save it, it rejects it, it fails because Java has to do value of enum.value of, and the database columns that are backed by enum, they are annotated with @enumerated, and then you specify, and the type of the variable is the enum. So if you have yes, no, unknown as the type of a variable in an entity, and maybe in the UI module, you added maybe yes, no, unknown, then you added not sure, just as an example, you added not sure as a new value in yes, no, unknown. And then you rebuild just the UI module. So when the UI will run, you will see it in the dropdown excellently. You select it, but when you save it, the backend will reject it because Hibernate or JPA tries to do value of for that enum, and the version it has does not have that. So there are inconsistencies. You could also have database migration issues where persisted values contain the new enum added, for example, but older components do not have it. So you have that problem when you're migrating or deploying a new version as well. Then intermodule communication, you have issues there, because the versions of SORMAS API they have are not the same. So how to solve this problem? Why we took time here is because this is the cause of a lot of errors, no field, no source. These are common things that arise in the log file. And to solve this is anytime you edit anything in the SORMAS API module, run a maven install in the SORMAS-base directory. SORMAS-base is not a development module, is the aggregator, is the parent module for all other modules. So you run install on it, then it will properly build the whole system in the right order. And every other module, depending on SORMAS-API, will have the correct version. Then you have to redeploy all your artifacts, even though you worked only on the SORMAS UI, but touched something in SORMAS API. Rebuild the entire project and redeploy both the back end, the REST, and the UI as well. So one key important thing here is that any change in the SORMAS API module cuts across other modules. So always rebuild the full dependency anytime you do this. This is to avoid hard to diagnose errors, because you're looking at the API module, you're seeing the new enum, and you're wondering what's going on. Yeah. Now, some other issues that can come up during development is when you have libraries and dependencies that are not available in the Pyara library directory. So the scenario here is that, so let's say you're working on a new feature of SORMAS, and to help you build that feature, you needed a certain third-party library, and then so you imported it into your Maven POM file, and then so and you complete your development. Everything runs successfully because Maven is able to reference the jar files for that library locally from the Maven home directory. And then you package your UI, whichever module you worked on with the new custom library, and deploy it. When you've done that, you see that the deployment fails. You get a common issue, either the application fails to start, or you get no class definition found error, or class not found exception, or features depending on the custom library just fail silently, which is where deployment appears successfully, but they are just errors when you try to use it. So the cause is that the third-party libraries are not in the path, runtime class path of Pyara. Custom dependencies are not bundled with the module build artifacts. They are not. Only the SORMAS minus API is bundled together with them. So they are therefore not visible to the application server. So how do you resolve this? You have to copy the required dependency jar files into the SORMAS Pyara domains library directory. So that is in OPT domains SORMAS lib. You paste them there, and then you restart Pyara to reload the class path. And this should resolve this particular issue. Another issue that is commonly faced during development is missing generated internationalization constants. So the idea is this: you've added a new key into captions.properties, enum.properties, strings.properties, validations.properties, whichever one, but you cannot reference the keys from code. And then, your IDE, knowing how your code base is, could even suggest something, and you take it and then you try to compile, then you have these errors when accessing constants. Or UI labels, captions, they don't resolve correctly, despite these keys being present in the property files. So the possible cause is that you did not execute internationalization constant generator after modifying internationalization property files. This is important. This class, because you cannot remember all the possible keys in the property files, SORMAS makes this easy using some classes that hold constants that reference these properties. Now, those classes, you do not modify them by hand. Okay, they are generated automatically. And how you generate that is by executing the main method in this internationalization constant generator. This is the name of the class, L18 and constant generator. So it produces the constant classes based on predefined lookup types. So these classes, they are not dynamically derived at runtime. And if you update them manually, you'll still run into issues. So how do you solve this? Anytime you update any of the properties files for internationalization, quickly go to internationalization constant generator and execute the main method and commit the generated files to your Git history. Then rebuild and deploy the affected modules. Never manually modify these classes. So this is the class, internationalization constant generator. You can see it's in the API module. So basically, what this class does is to scan the class path for these property files. You can see captions.properties, you can see strings.properties, you can see validations.properties, countries, and descriptions. And it generates Java classes named according to the properties file's name. For example, you have a class called captions.java, strings.java, validations.java, countries.java, and descriptions.java. So just to have an idea of what this looks like, so let's say, so this is SORMAS API captions.java. So you can see it basically has strings that points to the keys in the properties file. So this makes it easy for you to look up the property key while coding in the UI module or in any other module you want. Okay, so you can see also you don't come here to manually edit this file. No, you have to run that class and it will help you to generate this class correctly. Okay, so you can see these are all the captions for case data, DTO, and things like that. So same thing you have for strings. So you can see as well, these for strings. Then you have for validation. So validation messages, in case you added a new validation message in the validation.properties file, you have to run. If not, your code will not be able to look it up. Now, the next issue that you could run into while developing is a very frequent error that happens. That's when you're redeploying the SORMAS backend module, which the module is called SORMAS minus backend, but the build artifact is called SORMAS minus ear. Okay, so you may not see SORMAS minus backend.ear. No, it's called SORMAS minus ear.ear. Now, usually sometimes when deploying this, you get this error, too many errors, annotation processing abandoned. This usually occurs after repeated, as you're developing, repeated deploy, undeploy, and redeploy cycles, which is common for doing development. So the likely cause of this is that the application server's processor for annotations and class loader state, kind of becomes inconsistent after repeated cycles of deploy, undeploy, redeploy actions. Or there is still class metadata, and Payara is not refreshing that metadata. Or unloaded classes still remain in memory. So this can be caused by several things. It's environment related. It's not a defect of the SORMAS code at all. How do you resolve this? At that point, you stop Payara fully and restart Payara server locally on your development machine. So this will clear the caches for the class loader, clear annotation processing state, and kind of refresh the entire environment for SORMAS minus ear to be deployed. Then after the Payara starts, simply redeploy SORMAS ear, and that resolves the problem. If you keep trying to redeploy as it's failing, you continue to see this error reported on the terminal or in the log file. Thank you, everyone. This brings us to the end of this tutorial. The foundation has more tutorials planned around SORMAS development, and we will send you notifications when those are ready. In the meantime, if you have further questions or want to reach out to us, please visit our website, sormas.org, and reach out to us by email.